Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra 2 class. All right, guys, we're going to continue with our rational expressions. Sometimes they're called complex fractions. Don't let the name scare you. Oh, complex fractions. I know fractions are everybody's nemesis, and you add the word complex to that, and a lot of people freak out. Don't let it freak you out, please. It's not that bad. When we're multiplying rational expressions or complex fractions, guys, it's just three simple steps. Number one, completely factor the polynomials in both the numerator and denominator. Done. Factor them. Number two, rewrite the simplified numerator and denominator once you've already factored them. Number three, cancel out the common polynomials from the numerator and denominator. Notice what I said here, please, gentlemen. Common polynomials. Remember what we talked about ad nauseum yesterday. You cannot cancel out individual pieces of polynomials. What does that mean? Again, I'm not going to take too much time on this, but just to make sure, if I have x plus 2 times x minus 5 over x plus 2, or x plus 5 times, let's say, x plus 2. I can completely cancel out the x plus 2 with the x plus 2 because those are identical polynomials. But I cannot say, oh, Mr. Moore, look, let's get rid of this x, let's get rid of this x, let's get rid of this 5 and this 5, and I'm left with a negative 1. No, you cannot do that. We're going to reverse all of that because that's not possible. That is impossible mathematically speaking. This is done. You are left now here with x minus 5 over x plus 5. Those are not identical polynomials. You're done. You cannot simplify or cancel out individual pieces of polynomials. And that's it, literally. So let's do it. If you know how to factor, you are going to do very well. If you don't know how to factor, I suggest you learn quickly. So let me get to it. Excuse me. Let's factor. So this is going to be x plus 3 times x minus 2 over x minus 5. This is actually, guys, one of my favorite. I know I'm a bit of a math dork, but this is one of my favorite chapters because it's kind of fun. I know. This is fun. Yeah, it is. Because it's kind of like a puzzle. Now from here, once you factor, this is why I like it. Now it's just a bunch of canceling. Bing, bang, boom. Done. Now I've got x minus 2 times x plus 5 over x plus 1. I'm done, y'all. Bing. Done. Bye-bye. Have a good day. And that's it. Yes, sir. If I multiply them together, then I'm going to complicate things, my brother. I am trying to find things in simplest form. Thank you for your question, though. It's a good question. Thank you. Next, let's factor. So I take out a 2. I got x minus 4 over. This is a difference of squares. So that's x plus 4, x minus 4, times, this is x plus 4, times x plus 1. And then here, this is a perfect square. So this is x plus 4 times x plus 4. Now I'm sure some of you are saying, oh my God, how does he do it that fast? I learned how to factor. I suggest you learn how to factor as well, and you're going to have no problem with this. The x minus 4 and the x minus 4 cancel. This x plus 4 cancels out with this x plus 4. And I'm done. So I've got 2 times x plus 1 over an x plus 4 times an x plus 4. So that's an x plus 4 squared. Done. Literally. Next, I've got an x minus 3 over 5 times factor out a 5 here. So I got x plus 7 over difference of squares, x plus 3 times x minus 3. A 5 and a 5 cancel because they're monomials. The x minus 3 cancels out with the perfect x minus 3. They're the same binomial. So I've got an x plus 7 over an x plus 3. Ding dong, the witch is gone. Have a good day. Now, here I factor out a 7, and I've got a y plus 4 over 4y times 8 over, this is a y plus, let's see, 4 times a y minus 2. The y plus 4 cancels with the y plus 4. Okay, 4 goes into 4 one time, 4 goes into 8 two times, and I'm done. I cannot cancel anything else out. 7 times 2 is 14 over y times y minus 2. So I got y times y minus 2. In case you're wondering, why aren't we stating the excluded values? We weren't asked to. If we were asked to, we'd have to do it in this stage here, not in the simplified stage. Remember, if you're ever asked for excluded values, the steps are factor, excluded values, then simplify. You had a question, my brother.
No, I wanted to see it.
Oh, sorry, my man. Yes, sir.
Like just straight from
I'm just simplifying here. I'm not asking for the excluded values, sir. If I was asking for the excluded values, it would be factor, excluded values, then simplify, my brother. Thank you so much, son. Thank you, thank you, thank you. Make sense? Okay. Okay. I'm going to skip E because I'm running out of time, but I like to do F because there's a little Cuban method here. So let me give you a refresher on the Cuban method here. So, for F, first of all, what did I tell you when you have a leading coefficient that's negative? Very good. I'm very proud of you, son. So let's factor out a negative 3x out. Very good. So then I'm going to be left with x minus 5. Very good, gentlemen. Over 7 times, this is 2x plus 3. Now, Cuban method. 2x, 2 times negative 15 is negative 30. What times what is negative 30, but when added together is negative 7. Negative 10 and positive 3. Very good, son. Take out a 2 here, so this is x minus 5 times 2x plus 3. The 2x plus 3 cancels out with the 2x plus 3. The x minus 5 cancels out with the x minus 5. So my answer here is negative 3x over 7. Got to remember all of your factoring techniques. Not just remember them, you got to be wicked good at them. Got to be wicked good at them. Okay? And then, that's multiplying. Dividing is the same exact thing, except we got to do state change flip. So we complete the division process. State change flip, we know that. Completely factor the polynomials in both numerator and denominator. Rewrite the simplified numerator and denominator. Cancel out the common polynomials from numerator and denominator. Literally the same exact thing. So, first of all here, I'm going to factor out a negative, right? So stay, but I factor out a negative. Stay. I'm going to factor this out. X plus 1, x plus 1. Change to multiplication. Flip. So x plus 1, x minus 1. And this is x plus, no, this is going to be, yeah, no, this is right. X plus 5 and x minus 2. The x minus 2's cancel. On x plus 1 cancels. And I'm left with negative x minus 1 over x plus 1 times x plus 5. Stay x plus 4 times x plus 1, x minus 4 times x plus 3. Change to multiplication. Flip. Take out a 2x. Got x minus 3 over x plus 1, x minus 1. X plus 1's cancel. And wow, that's it in this case. Yep, that's it. So this, so this is a 2x times x plus 4. Sometimes a lot of things cancel, sometimes not so much. And then this is an x minus 4, an x plus 3, and an x minus 1. Stay, change, flip. Stay, x plus 1, x plus 7. I'm going to do this last one. If you guys want to go to lunch, you are dismissed. God bless you. Thank you. I'll finish this last one. Homework is valid. Check the calendar. Hope you learned a lot. Have a great day. God bless you. So this is x plus 1, x plus 7 over x minus 4 times x plus 3. So that's stay, change to multiplication, flip. X plus 5, actually x plus, let's see, what times what is 24, but when added together is 13, is 12 and 1. No, not 12 and 1. 12 times 1 is not 24. So we got 6 and 4, no, 3 and 8. No, actually that is not factorable. So this is just x squared plus 13x plus 24 over, this is x plus, let's see, this is x plus 4 and x minus 2. Okay, that's a bad one. That's a very bad one because this is not factorable here. This should have been, let's see if we can change this. It's 24. Let's make this a negative. Yeah, let's make this a negative 10. Let's make that a negative 10. If we make that a negative 10, now I can factor it and I'll be able to simplify. So then if I make that a negative 10, I apologize about that. That will be an x minus 6 and an x minus 4. Now the x minus 4s can cancel, so I'd be left with an x plus 1 times x plus 7 times x minus 6 over an x plus 3 times x plus 4 times x minus 2. Stay, change, flip. Stay. Factor out a 2 from here, x minus 4. Change, flip. 2 goes into 2 one time, 2 goes into 4 two times. So this is 2x times x plus 3 divided by 9 times x minus 4. I cannot simplify that any further. I cannot simplify anything further. I cannot simplify this 9 and 3 because this 3 belongs to this polynomial. This 9 is a monomial by itself. Okay? Thank you once again, guys. Hope you learned a lot and have a great day. God bless you. Okay, guys. Hold on. Okay, for this is the same exact thing. This is a division bar. So this is stay, change, flip. So stay, factor this out, change, flip. This is x plus 4, x minus 4 over 4x squared. The x plus 4 is cancel. 4 goes into 4 one time. 4 goes into 12 three times. This x goes bye-bye. One of these x's go bye-bye. So I'm left with 3 times x minus 4 over 5x. Stay. Change. Flip. Take out a 10 from here. I got a minus b. The a's minus b's cancel. 7 goes into 7 one time. It goes into 21 three times. One c goes bye-bye. One of these c's go bye-bye. 5 goes into 5 one time. It goes into 10 two times. I am left with 3 over 2c. And you just continue with the same procedure. Thank you guys. God bless you. Hope you learned a lot. Have a wonderful day.